So we have this model built, and as I said, it may be a little bit different from some of you who weren't here for yesterday's session on bringing data into and out of spreadsheets. But don't worry about that. We won't be relying on that part of this. Okay, so you'll recall that this model was a model of that included a representation of a population. This population was heterogeneous, with differences both in the location of a person, their income, and over time, the number of times that they were infected. Do you remember that? Okay. We had individuals who were progressing in a natural history of infection described by, in this case, just one state chart, susceptible, infected, and recovered, and they lost their immunity after some time. Those individuals were further enmeshed in networks, right? So if we ran the model, many of you will remember what it basically looked like. But when we had this model up, custom distribution. Oh, I added a custom distribution to show something late in the game for Hideo. So let me get rid of those things. Those were just for me to show him some features. Okay, so I'll delete this, and I will delete this guy. Okay, so let's run that again. You should see something like this with a network, individuals placed in the network. Those individuals are placed with an X location according to their what? Anyone remember? What was the X axis representing? Their income. And so individuals who were higher income tended to have less crowding, be subject to less crowding. Remember that over on the right-hand side of this? Remember this? Yeah, okay. And because of that, there was a differential burden associated with crowding and thereby with prevalence of infection that we graphed out both in a form of different histograms and over time. Do you remember that? Okay. So today our focus will be a little bit different. We are going to be focusing on interventions. But before we do that, I actually want to place up a construct that will be used to summarize the state of the population by income and count of times infected. This will be a scatter plot. And we'll be examining the impact of interventions on this scatter plot, so that we can judge their effect, and it will teach a principle or two, okay? So I also want you to see how you can build these scatter plots. Does anyone remember Kurt showing a scatter plot yesterday? Remember that? He showed this scatter plot, which showed sort of a general trend downwards in the number of carries, the amount of time people had spent with carries, as one increased the socioeconomic level of people. We're going to create a similar histogram here, and we will use that then to understand, as a lens to understand the effects of an intervention, okay? So we're going to be using this model as a vehicle for pursuing that. So Emily, we're just working with this model that we've worked with over the past few days with the crowding disparities, and we're going to be investigating interventions, and as a lens to understand the effects of an intervention, we're going to add one final representation. Okay?
Did you say you reposted the one that you worked on yesterday?
Yes. Yes, it is. Correct. That's a good point. Okay, but you don't actually have to depend on that particular one. Let's go. I
just had a lot of errors from yesterday.
Oh, I see. Yeah. So I would just go to the models created in class, and then there was models built in class, and there was ABM crowding disparities, SK. This one should be fine. This one does not have any input or output from spreadsheets. This is the one as of early yesterday, before we did the importing of data from a spreadsheet and outputting of data to a spreadsheet. So it's this ABM crowding disparities. If you go there, where is it? Okay. This one will actually also do this ABM crowding disparities original. That would also be fine. For some reason, there seems to be a this doesn't seem to have an item in it. I would not do this ABM crowding disparities with output because it's as you say, it depends on my location. So I would do it the original one. Say that should be fine. Okay? Are people okay with this? Okay, does anyone want me to wait a little bit? Okay. Remember, you can download this by clicking on it and then by pressing download. Okay. Okay. Okay, Alan, could you see if you could help Robin here? There's a Mac specific issue having to do with download. Rename it to be .alp. Yeah. Okay, who else needs help? Who else needs help getting Daryl? Again, if anyone had this version of the model before, you should be able to use it okay. Okay, great. Great. Good. That's good. Yeah, that you can do browse and point it to, yeah. Okay, folks, are we ready to go forward? Does anyone need a bit more time? Okay. So again, we're going to be undertaking two broad tasks. The first thing is we're going to add a scatter plot. And then the second thing is we're going to go and investigate some interventions. And those interventions will themselves be of two types. One set of intervention will be a broad intervention across the entire population, one type of intervention. Another type of intervention will be very targeted at subsets of the population, okay? And we'll see how those can be defined purely in experiments without requiring you to hard code interventions into the main structure of the model, which is important. Okay, so ladies and gentlemen, the first thing I'd like you to do is to go to main here, okay? So within main, we're going to go add something we've never added before. We're going to go add a scatter plot, okay? Now, where would a scatter plot live, do you think? It's in analysis, is right. So it's in analysis. And you'll notice that you have a wide variety of types of charts here. One of them is this plot. And this is the one we want. Although it shows lines, we can actually eliminate the need for lines or eliminate the request for lines. So we're going to drag this into our model. And I'm dragging it, in my case, there's a histogram that we had built, and I'm going to drag it above that histogram. But you could drag it as you see fit. Okay, so we have this scatter plot that we've just dragged in, and I'm going to give it a name. This name will be income or maybe I'll call it count infections by income scatterplot. So in other words, it's going to show us on the x-axis someone's income, and on the y-axis, it's going to show the number of times they were infected. So I dragged in this plot to main, and I called it count infections by income scatter plot. Are people okay with that? Who needs TA help? Alan stands on guard. Yeah, I think that might be good. Okay. Okay, are people okay with that? Okay. The next thing I'd like you to do is to drag in a data set. Now, it turns out scatter plots, like another type of data of item that we created, depend on data sets to do their job. We used data sets yesterday in what way? Does anyone remember? Yeah, to import and export. We used them for histograms. Additionally, we had a histogram data item. Remember that? Here we're just going to use a regular data set, and it's going to be called count infections by income data set. Okay? Now, this is key. When we used this yesterday, we left this box checked. Does anyone remember that? Yeah? For now, we are going to uncheck this box. Thanks, Ellen. For now, we're going to uncheck this box. And Amin, if you are called off somewhere else, feel free to grab another TA if you need to be elsewhere. I see. Oh, the other TAs aren't in yet? Okay. Maybe you could send some text messages. Yeah, that could be really useful. It is a working day. Okay. So, ladies and gentlemen, we want to uncheck this item. We want to use both items of this data set. Rather than just labeling each data point with a time alone, we want to have pairs of data points. What do you think the pairs of data points will represent? Anyone? Income and count of times infected, right? That's exactly right. Now, over whom is this scatter plot going to represent that? Do you remember each point within Kurt's scatter plot yesterday? What did each point correspond to? A what? A particular person. So we're going to need to go through and put each person's data into this, much like we did with the histogram yesterday. Do you remember that? Okay, the king has entered the room. Okay, now we're in good shape. That's great. Sorry, Alan. Well, we did need another person, and Winchell has many years of extra experience, so it is good. Yeah. Alan is the prince in waiting, the crown prince, the crown prince, in the fullness of time. But Winchell's been here about 4 times as long as Alan. So. Okay, so ladies and gentlemen, we unclicked this use time as axis value, but we're going to need to refresh this. Now, this is a very important point of thinking, of reflection. Ladies and gentlemen, when we had a histogram, how did we get it to populate the data set associated with that histogram? What place was that done within the model? Does anyone remember? Okay. Well, when we had a histogram, who populated that data for the histogram? It was an what? An event. It was firing off periodically. In that case, once every week, right? Okay. Okay. So, ladies and gentlemen, we're going to add an event here as well. Where do events live in the palette? Anyone remember? In the agent. So we're going to drag in here, and we're going to say populate Scatterplot reporting event. So this is going to populate the Scatterplot. Okay. Winchell? Oh, sir? Officer? It's just that door to the stairwell there that was locked. I'm grateful. Thank you so much. Thank you. Sip to you. Winchell? It wouldn't be bad to think about a Scatterplot in the Alberta Health Services model sometime, just to summarize sort of, people's status over age and so on. So it's something to think about. But you'd want to do a sampling of the population. We can talk about it later. Okay. Okay. So, ladies and gentlemen, we're going to set this event. What sort of event does this need to be? Anyone? It needs to be a cyclic. It needs to be a cyclic event. That's right. And it'll go off at certain times. So we're going to do it every month. Okay. Oops. Every 1 month. Recurrence time. Is that okay? Feel okay with that? Okay. So we're going to have this reporting event going off every month. Okay, great. So now, ladies and gentlemen, we're going to need to do the hard work of populating this. And so you're going to tell me what needs to be done. We want it to give a fresh slate every month, the plot, to make this plot. What do we need to do up front? Yeah, we need to reset this data set. Remember that? Because we don't want to have all this sort of old data in it from earlier. So how are we going to reset it? Yeah, the count infections by income data set. We need to do reset, right? Great start. Once burnt, twice shy. Okay? Are you okay with that? Okay, now tell me what has to be done. Remember, we want one data point for each person in the population. Yeah, we need to loop over each person in the population. Okay? So, for person P in the population. So what does that P mean? When we refer to P, what is that going to represent? Yeah, one particular person. And each successive iteration of the loop, it'll be a different person. First person, second person, third person, fourth person. Just like that. Okay? And what are we going to need to do for them? Sorry? What are we going to need to do for that person? Add their data to the data set. Okay, so that's a great, so who do we ask to do some work? By the way, this should really be to be explicit with our convention. So what do we need to ask to add the data? Who are we asking to add the data? Who needs to add the data? Who do we need to ask to add the data? The data set. The data set. We need the data set to add the values, right? In other words, it is the one that has to receive the value. So it's the one who we have to ask, hey, add this thing, right? Can we try that? Okay, watch this. This dot count infections by income data set dot what? Add. Good. Add. Now you'll notice that there's actually two forms of add. I want to make sure that you folks understand. When you see this add dot here, when it's this autocomplete is your friend, and you need to get to know a friend and understand their habits. So this dot is an indication that there's actually several versions of this. So I'm going to press enter on that, and it shows me there's two of these. Which do you think we want? The first or the second? X and the Y. Remember that? Good, okay. So let's go do that. And we're going to add for the X value, the person's what? Income. So how are we going to say the person's income? Person dot income. So P dot income. Whose income is it? It's P's. Who is P? It's each successive person in the population. So that's one particular person right now. And then the next time through the loop, it'll be a different one. Next time through the loop, it'll be a different one. And then what do we need to add for their Y location? Count of times infected, right? Count times infected, okay? Now, we actually don't truly need these curly brackets here because we don't have more than one line in here. So if you want, you can just turn it into this. That's also fine. But in general, if you have curly brackets, it allows you later to maybe put in something that prints out something or whatever without worrying that it's knocked out of the loop. So if you have more than one statement in there, you need to have the curly brackets. Otherwise, you don't. Okay, are people okay with this? Do you want to try building it? Do you want to try running it? Yeah? I like to add a line here just to keep it nice and sort of spread out. This is cleaning out the old data. This is populating the new data. What else do we have to do? Yeah, we have to link it up to this guy. Okay, now this guy is, what do we have to do to link it up? Okay, so we need to do add data, and we need to refer it to a data set. So we're going to call this, I'll just call entire population. I mean, I'm not showing subsets of the population. And then what's the data set? Count infections, yeah. Count infections by income data set. Okay, now, folks, I would like you to do not update data automatically here. Okay. Do not update data automatically. I don't think we should need that. Okay. Yes, you notice it says applies to value data items only, and this is not a value data item. Yeah. Okay. So shall we build it? Shall we run it? So every 1 month, this thing should go and update this. Why is it all blank? Why is it all flat right now? Anyone? Why is it all flat? Well, everyone started with no previous count of infections, right? Now, we haven't even yet reached a month. Notice this thing is flashing red here occasionally. I don't know if you've seen that, but it actually flashed red for a bit. That's a sign it's going over. It's sort of getting short of memory and cleaning up a bit. So, we're probably going to want to increase the amount of memory devoted to the simulation. Okay. Now, it looks like this infection didn't actually catch. In other words, there was one person infected. So I'm going to actually run this again with a different random number seed. Okay, it's trying to write it out. Okay, fine. I'm not going to worry about that. That was yesterday. This is today. Okay. I'm going to run it again, and we're going to see this, see it for a different run. I think by the luck of the draw, we didn't have an outbreak last time, so it wasn't that interesting. Okay. Nope. No. Remember, that was experiment specific. Okay. So, ladies and gentlemen, I'm going to go to this simulation. I'm going to increase the amount of memory available to it because it was short of memory. So we go to the simulation experiment, and we pull down, and I'm going to give it 1 gigabyte of memory. Winchell is used to having to give simulations considerable amounts of memory. Okay. Okay, so we're going to run this. I did that by going here to the experiment, scrolling down, and selecting maximum available memory. Okay? I'm adding it to the one that I'm running. I'm giving it 1 gigabyte of memory, so it doesn't get so chronically short of memory frequently, which will really slow it down sometimes. Okay, so ladies and gentlemen, I'm going to run this thing, and hopefully we'll get an outbreak this time. No outbreak. Still no outbreak. Okay. Great. Okay. No. Okay. Suppose we wanted to be able to, I could run this thing again. I'm going to go down and see if this is a random number seed. Yes, it is random. So we should be able to eventually get one going without problems. But let me ask this. Suppose we want to click on a given person and infect them by clicking on them. How would we do that? Yeah, the on-click handler. That would allow us to start an infection, even if it didn't happen by chance. We could do that quite readily. I'm not going to go there unless there's strong demand for it, in which case I could show it. Okay, so I'm going to run this again, get to a simulation where, here we go. Okay, so now let's go up, and there we go. What's wrong with this picture? Anyone? Well, it has these lines. Let's get rid of the lines. You see that? Okay, so let's go get rid of the lines. Where do you think we'd need to go to get rid of the lines? Is that a data problem? No. It's a problem of display. So we go to the Scatterplot, and if we scroll down, there's this area appearance. Do you see that? And there's a thing called draw line in it. Do you see that? So we want to uncheck that. Having done that, we will then go run it again. Who needs more time? So what did I do? I went to main, to this chart. I scrolled down to appearance, and I unselected draw line. Having done that, I should be able to run this model, and we should be able to see this plot here, which is displaying the burden of infection. It's dictated by the number of times someone has been infected by income. What do you see there? What are these kind of ants crawling up the wall? Well, the scale's a little bit off because most of the people are clustered here. But what you could see is the burden of infection tends to be higher in which group? Low-income group. And that's what we see in this histogram as well, right? So here we have the low SES population here, whereas for the high SES, we have large numbers of people captured down here. About 50% of the population has essentially no burden of infection. So suppose we wanted to zoom in on this area between 0 and 10,000. How do you think we do that? Anyone? Yeah, you go to scale. So we're going to go in there. We're going to go to scale, and we'll zoom in. And what do you think? Is this horizontal scale or vertical scale? Horizontal will go between 0 and 10,000. Is that okay? For this scatter plot, went down to scale, went to set it to be a fixed horizontal scale between 0 and 10,000. Are people okay with that? Who needs more time? Okay, should we run it? Okay, here we go. Okay, we can go up, and what we'll see now is more nuanced. What does that demonstrate? There exists a gradient associated with burden of illness, associated with number of times, as judged by number of times infected, that it's a burden over income levels. So it's a disparity associated with income. So those who are lower income tend to have a higher count of times infected than those who are higher income. Do you see that? Okay. So watch this graph. We're going to be modifying it as we run the simulation. Okay.
Is there a reason why the vertical axis keeps going up in the same way? Like this is climbing 200.
Yeah. Well, let's go. You'll notice this is climbing as well, right? The histogram, the x-axis along the histogram, it's climbing. Let's go down to the level of an individual person. You notice this person, how many times have they been infected? A lot of times. Think of it as some sort of common cold or something like that. They've got infected many times. Over time, it's a running count of the number of infections that they've suffered. And that's a very stylized model. And so we're depicting that as occurring quite frequently, which may not be all that unrealistic if it was a burden of common cold. And as a result, this keeps on climbing, as does this. By contrast, the prevalence levels are not changing that. This is the fraction that are infected right now, so they're not needing to climb in that sort of way. But these are. Does that make sense? So basically, each person is rising in the number of times they've been infected. Okay. So people need help getting to this point because we're going to be building on top of this now. Yes, Luz Maria.
When I opened the new model, for whatever reason, the count sensitivity gets too high, I don't have that.
The count of times infected?
Yeah, is that easy to set up? Not just follow.
It's very easy to set up. Can we do it? Yes. I'll tell you how to do it. Well, you tell me. How would I set up? Okay, so Luz Maria has a missing count of times infected. She does not have count of times infected within her model. So how could we add this for her? Where does it live? It lives in person, right? Okay, so let's go to person. What mechanism do we need to keep track of the count of times infected? Is it a parameter? Is it a state chart? Is it a event? What is it? Okay, it has to do with the state chart, but what else do we need to keep actually track of it? We need a variable, count times infected. So Luz Maria, so if you go into person and you add a variable called count times infected, what sort of variable would that be, ladies and gentlemen? It's an integer. It's a count. 1, 2, 3, 4, 5, 6. Zero can actually, in general, an integer can be negative, but in this case, it's starting at 0. Its initial value is 0. And from then on, it's going to change only upwards or stay the same. Okay, so ladies and gentlemen, Luz Maria, did you add that? Okay. So where would we need to increment this variable to help Luz Maria? We need to do it in the, say, the entry action for infective or in the infection transition. We actually did it here in the infection transition, and this is what we put. We put this dot CountTimesInfected plus plus. Arash? Okay. Is that okay, Luz Maria? Okay. So are you able to now make use of that in that main main event? You will now refer to this CountTimesInfected. Excuse me. This is the earlier one. That was for the. Excuse me. Yes, that was for the other one. This is for the Scatterplot. We'll be referring to that there. Is that okay, Luz Maria?
Yeah. So I just have a question. When I tried the CountTimes Infected, why is it the auto compute doesn't show that value?
That might be something Alan could help with. So is it right here? Is it right? You're saying in this place?
Yeah, so I tried, and it doesn't give it for me to find it, and that.
Even after you added it? Okay, you might want to do build. The Winchell might also, but if you have duties there, Winchell, no worries. Is it a Mac issue?
I just looked at a Mac and
Okay. Okay. So, okay, so are we okay with this? So if so, we are going to be able to move on to the next step. So I'm going to stop this. I'd start recording.